Hello and welcome back. Today we're back on PLC IOSim. We're going to do the final 2 levels. If you didn't see the last video, I'd recommend it. We tackled this number 27. It was quite the learning experience. So yeah, we'll just get right into it. But first off, just smash like and subscribe. Level 27 wants us to design a program to control a railroad crossing. Pressing the open push button should energize the reverse motor, causing the gate to open until the up limit switch is activated. Pressing the close button should energize the forward motor, causing the gate to close until the down switch is activated. Pressing stop at any time should stop the operation. While either forward or reverse motors are running, both lamps red left and red right should be energized. So in order to open the gate, we can use this open command. So we'll make a contact in our logic that will close when we press open. And when we release open, we want this process to latch. So we'll use a latching command. And this will go to energize the reverse motor. Now to turn off the gate from opening, we can do one of two things. So I'll make a parallel set here. First way to stop the gate from opening is automatic, and that's when the gate goes all the way to the top. When that happens, this up limit switch will become closed, and so we'll use this normally open contact here that will close when the gate goes all the way up. We can use this to unlatch the reverse motor. Now the other way to get this to stop from opening, we should be able to press stop at any time. So because the stop buttons are normally closed here, whatever contact we put in here will be normally energized. So I'll put in a normally closed contact to represent stop, because if it's energized it will be open. Only when we click stop will this actually become closed and send a signal to unlatch the reverse motor. So let's just give that a quick try here. I'll go to run mode, I'll click open, and it should automatically stop because this up switch should close when it gets to the top. And you can see that sends a command to unlatch the motor. So now we'll need a way to close this gate again, and it's going to be very similar to what we just did. We'll just use our close push button, and we'll use that to latch the forwards motor. And to turn that one off, it will be the exact same. You can see this down switch opened up. So when we get to the bottom, this down switch will close again. So our logic will actually be the exact same to turn off closing the gate as it was opening the gate. So we'll have our down limit switch in parallel with our stop command. And both of those options can be used to unlatch the forwards motor. So if we go to run the program now and click close and let go, you can see the gate will close and it should automatically de-energize the motor when it hits the bottom and the limit switch closes. So that's good. Now let's just make sure our stop button works. We should be able to press it at any time. Sweet. So the last thing we have to do is to make it so that either when the forward or reverse motor is operating, both of the red lamps turn on. So we'll make another parallel branch. One of the contacts will close when we're going forwards, and the other one will close when we're going in reverse. And this way, as long as the motor's running in either direction, a signal will get through here. And we can use that signal to do two more things. We can have it to turn on the red left and also the red right. So we'll run the program here. And you can see the lights are off. But if I go to open the gate all the way, you can see both of the lights turn on. And then it should stop. And the lights will turn off. And yeah, we'll go and close it. And then the lights will turn off again. And just for fun, because I've never actually seen a railroad crossing control like this, I added a flasher. So you can watch if I go and open the gate, the lights actually flash back and forth instead of just staying on. And I think that's a lot more realistic. So how I accomplished this was by building a flip-flop here. It's basically a feedback loop between these two separate timers I set up. And we're using complementary contacts from one of the timers so that only one light is on at a time. And so I covered this flip-flop scenario in a previous video, so I'm not going to go over exactly how it works, but I'd encourage you to try and figure it out. And like I said in the other video, this isn't like the most intuitive way to make a flip-flop like this, but it's the only way I can figure out how to in this software. So yeah, that was fun. I hope you liked it. We'll just go to the next one, which is the very last level on the list currently, sequencing. So for our final challenge, they want us to design a program to control the sequencing of two lamps. Pressing PB1 should begin the sequence and energize lamp 1 for 2 seconds. Then lamp 2 should energize for 2 seconds. Then both the lamps should turn off. So we'll just make a contact for our push button, and we'll have this feeding a on delay timer. We could set the timer to 4,000 milliseconds, or 4 seconds, because our whole sequence is 4 seconds long. The first lamp will turn on for 2, and then the second lamp for 2. So for the first lamp, this will be fairly straightforward. We can have that connected directly to our timer timing bit, so t1.tt, and that timer timing bit will be equal to 1 as long as this value is still counting, so basically for 4 seconds. And this way, when you hold PB1, lamp 1 will be on for 4 seconds. Now the only other thing we have to do is make it so that light 2 is on, but just for the second half of this cycle. So to do this, we could just use some comparisons. So we can say if timer on 1.acc is greater than or equal to 2000, then we can turn on our second lamp. But this is going to be a problem because then this lamp won't turn off when the timer finishes, because then ACC will just stay at 4,000. I'll show you. So it's good. It turns on after 2 seconds, but then it doesn't turn off with lamp 1. It should turn off with lamp 1. So there's a couple ways to do this, but like what just makes sense is just to put lamp 1 here. And this way, as soon as lamp 1 turns off, so will lamp 2. And the only way to restart the sequence is to just click the button again. So that's as easy as that. And unfortunately, it looks like we've gone through all of these problems by now. So I hope they make some more ones soon. In the meantime, yeah, leave a comment if there's any sort of specific videos you guys want me to make. I'm open to ideas. Yeah, I'll just be waiting for more of these and thinking of some more stuff to do. So I hope you guys are enjoying this series. If you do, smash like and subscribe. Go ahead and check out this website, PLC IO Sim. And yeah, thanks for watching.